Welcome and thank you for joining me. In this lesson, we'll explore the inverse trigonometric functions. Recall that if we're given the value of an angle, we can determine the respective trigonometric ratio by simply typing the expression in the calculator. There is nothing new or fancy in here. We've done this in the earlier grades. So to find the sine of pi over 4, you simply type in sine. You type pi, you type divide, you type 4, and then you type equal, and you're going to get the answer. And in most calculators, you will get the exact answer, even when the answer is in radical form. So in this case, what I'm going to try to do is, since the angle pi over 4 is a special angle, I'll use the special triangles and do this manually. And this can be a review of how to use the special triangles to find the exact trig ratios. So pi over 4 is also known as the angle 45 degree, and it's in the special triangle 1 root of 2. And these are measurements that you have to memorize for now. And here is the angle pi over 4. We're going to say that the sine of pi over 4 is opposite over hypotenuse. In our case, 1 divided by square root of 2. So this would be the answer. And the more simplified form of this answer would be found by simply conjugating, we call it, the denominator. Remember that when we have radicals in the denominator, it's not considered to be the most simplified form. And if you multiply root of 2 by root of 2, we get a radical-free denominator, and that will give us the square root of 2 over 2. So both answers are acceptable at this point, but this would be considered the more simplified form. So in the next example, we have something similar. So pi over 3 is a special angle of 180 over 3, so that's 60 degrees. You can find the cosine of pi over 3 using your calculator. And I would recommend that you use the angles in degrees if that is too difficult for you while you make the transition learning degrees and converting to radians. And what I'm going to do is draw the special triangle. This time, I'm going to draw the special triangle that contains the angle 60, and this would be the 1, 2, root 3 triangle. Again, these are measurements that we need to memorize. And this is angle pi over 6. We're finding cosine, which means we're using adjacent over hypotenuse. So in this case, the cosine ratio will be 1 over 2. So in the next example, we have a tan ratio of angle pi over 6, which is also a special angle. So I'm going to use a special triangle for it. And that would be the triangle 1, 2, root 3 again. And here is the angle pi over 6, or 30 degrees. So the tan of pi over 6 will be the opposite over adjacent, so that's the TOA ratio, which means that we have 1 over root of 3. In a more simplified form, we can multiply this fraction by root 3 over 3, which is basically multiplication by 1, and that will give square root of 3 divided by 3, which is, again, considered to be the more simplified form of it. So in the next example, we're going to take a look at exercises where we are given the trig ratio and we have to find the unknown angle. So if you remember this from the earlier grades, in order to find the angle theta, we are going to use a special button in the calculator, and it appears actually in different names in different calculators. So I'm going to write the more common symbols that we use. So remember that the button that we use in order to access the angle theta here or evaluate theta in some calculators will be the second. That's exactly what it's written on that key on the keyboard of your calculator, or the shift, and this would be the more accurate way of describing what that button does, so the inverse. So we are going to type in inverse and then the sign. And when you do that, on the screen of your calculator, you will see sine -1. And -1 sits in the spot of the exponent, but it's not actually an exponent. It's just a symbol for the inverse of the sine ratio. And then you type in the 1 over 2. So in these examples, or in these cases, I would encourage you to use the degrees if you have if you use a calculator that doesn't give the exact values, so it will give you decimals if you use radians. And if you use degrees, that will give you an angle of 30 degrees. And you can convert afterwards in radians if the question is asking for your answer in radians. So next we have cosine theta equals square root of 2 over 2. Again, we do the same thing. You can use a calculator to access inverse of cosine and then root 2 over 2. And if you're wondering, okay, so what does inverse mean and why are we using this? So the idea behind it is that we are using the value of the function to find the value of the independent variable. So we kind of have to invert the function, so we have to use y to get the x value, and that's the whole process of inversion means in this case. So cos negative 1 root 2 over 2 will give us angle 45 degrees if you use the calculator in degrees, or pi over 4 if it's on radians. So next we have tan theta equals 1, so again that would be inverse tan 1, and that will give the angle either 45 degrees in degrees or pi over 4 radians if you are using radians again. So we're going to say that to find the angle given the trig ratio, we use what we call the inverse function in the calculator. So I'm going to write this down with big letters. All right. Now, the whole process that we are describing here, even though it's a very familiar process for us, it contains a very major concept, as a matter of fact, because if you think about it, if the number here inside the sign, so if the trig ratio continues to change or becomes a variable, that will give a list of values. So that will create a function on its own, which we call the inverse function. So recall that the primary trig functions are y equals sine of x, y equals cosine of x, and y equals tan x. And in the lesson prior to this, we looked at the reciprocals, which are 1 over sine or cosecant x, or y equals 1 over cosine, which is secant x, or y equals 1 over tan, which we call the cotan x. So the inverse of a function is a reflection of the function about the y equals x line. And that works for any inverse function on the y equals x line. So what are the inverse functions? We're going to start off by naming them. So we are going to inverse the sine function. So I'm going to write sine of x. We're going to inverse the cosine function, and we will inverse the tan function. It is very easy to name the inverses. So all we have to do is add arc in front of each trig function. So the way we read them is arc sine, arc cos, and arc tan. So in order to best understand how to graph these functions, we are going to first take a look at some expressions where inverses are more heavily involved. So we're going to start off with sine inverse root 3 over 2. Again, we're going to simply use the calculator. So we're going to say that sine inverse root 3 over 2 means that we are inversing the ratio in order to obtain the angle. So the answer that we obtain in here would be, or would represent, an angle. So inverse sine root 3 over 2, if you use the calculator, will give you the angle 60 degrees or the angle pi over 3. Next we have inverse cos root 2 over 2. Again, you're going to use the inverse button and then the cosine, and then you have to type in the value of the ratio. So that will give or represent an angle, right? Because when we inverse a fraction or a ratio, we obtain the angle. So that means that the angle theta would be, your calculator most probably gave you the angle 45 degrees, and I will convert this to radians, which is pi over 4. So similarly, we're going to find tan negative 1 root 3, that will represent an angle. And when you think about it, so if you have the root of 3, it seems like a special ratio. So simply use a calculator So this would be the 1 to root 3, and tan of root 3 means that you have opposite over adjacent, which means that right here must be sitting the angle pi over 3 or 60 degrees. And obviously you can use the calculator, but I encourage you to always add more meaning to the answers your calculator gives you, because as we all say, calculators are as smart as we are. So we're going to move on to example number 4. So in this example, we have the more than one ratio involved. So we have to find the sine -1, so inverse sine, cot10 of pi over 4. So the way we like to see this is, first, identify what's inside in brackets. This is what we call the inside function, and then what's outside it. So we're going to work with the inside first. So the inside is cot10 of pi over 4. So the cot10 of an angle. So that means that inside, if you think about it, you have the ratio of an angle. So you know that the tan of pi over 4 is 1. So that means that cot10 of pi over 4 will be 1 over 10 pi over 4, or 1 divided by 1. So that means that the cot10 itself would be equal to 1. Now, remember that the expression here involves also inverse sine, which means that what we are trying to do in here is take the inverse of this expression inside the brackets. So the inverse of 1 in other words. So use the calculator at this point, and inverse of sine of 1 would be 90 degrees, or pi over 2 radians. So in the next example, as you can see here, we have cosecant on the outside, and then we have inverse cosine 1 over 2 on the inside. So again, we have to identify what's inside first, and then work on the outside after. So inside we have inverse cos 1 over 2. So what does this entire highlighted in blue expression represent, or term we can call it, because it is a single term? So that will represent an angle, because that's when we use the inverse. So when we inverse cosine, we get an angle. So inverse cosine 1 over 2 would be the angle 60 degrees, or pi over 3, same idea. So what that means is that we are now trying to find the cosecant of 60, or cosecant of pi over 3. It's the same thing. So remember that cosecant is the reciprocal of sine. So what that means is that we can write the same expression as 1 divided by the sine of pi over 3. So we know that pi over 3 is the angle 60. It has the ratio of root 3 over 2. Again, you can use the special triangles for it. So when you reciprocate root 3 over 2, we obtain 2 over square root of 3. So in a more simplified form, again, you can multiply by root 3 over 3, and then you get 2 root 3 divided by 3. So check your answer if it makes sense or not. Oops. So this is a ratio, and we expect to get a ratio because we are getting the cosecant ratio of this particular angle. So we are going to take a look at one more example. We have tan -1 secant pi. So I want you to first think, would I be getting an answer that represents an angle or a ratio in this case? So if you look at the inside, in the inside, we have secant pi. Secant pi will represent a ratio of secant of angle pi. So if you inverse the ratio of an angle, then you obtain the angle. So your answer represents an angle. So let's start off with the inside function. So we're going to say the inside term or inside function here is secant pi. And we're going to say secant pi would be 1 over cosine pi. Now, cosine pi is -1, so that means we have 1 over -1, and 1 divided by -1 is simply -1. So remember that we are taking the inverse tan of it. So that means that we have, make it a little bit thinner. Okay, so here we have inverse tan, 1 over cos pi. So that means inverse tan of 1 over negative 1, right? And inverse tan of negative 1 will give us the angle theta equal to, so think about the tan ratio of negative 1. If you are on the Cartesian plane, you can simply use the calculator, obviously. But the tan ratio of 1 will be here for angle 45. Negative 1 will be the angle 135 degrees. So I would say 135 degrees, or we can go 1 pi over 4, 2 pi over 4, 3 pi over 4. And that would be the answer for question C. So we will continue the next examples in the upcoming video. I hope that this made sense, and thank you for following me. Bye for now.